Everybody doing? Are you still surviving? Okay, so I want to introduce you to something of interest. I call it water for food, virtual water for food security. This is an interesting concept which you need to consider, and this is mostly important for the lowland, but it has a lot of importance for mountains. So let's see what this all means here. Remember, we need to increase food production by at least 50% over the next 30 or 40 years. Because we got 2 billion new people, we got about 800,000 which don't have enough food. We have 1 billion people who change their diet. We have about 3 billion people who move into cities. And we are now diverting a lot of the food for biomass, food biomass for ethanol production, and that's not very good either. So remember, agriculture uses about 70% of all the water resources, and only about a quarter of all the land is irrigated, but produces about 40% of the food. So that's the food situation globally. So only 20% of the agricultural land is irrigated with 40% of the food. In some parts of the world, water is so scarce for agriculture that you need to have a water meter for every olive tree. This is in the island of Crete, where they have mostly limestone, so their water resources are so scarce that they actually metered the water use for every tree. This is about as extreme as it can get. So agriculture uses about 40% of the terrestrial surface is used for agriculture. About 87% of it is used for food production. The rest is used for biofuel. And the environmental impact of agriculture is actually quite substantial. Globally, we think about 13% of all the greenhouse gas is from agriculture. And if you add the production and consumption part, it's about a quarter of all the world's CO2. It also acidifies, agriculture is now the big acidifier of the land, and about 3/4 of all the pollution in rivers and lakes is actually from agriculture, mainly from eutrophication. And again, the water use for irrigation is going to change very quickly. What you probably didn't know is what is the largest crop we produce in the world? If you look at all the food items we produce, what is the largest amount of food we produce per crop? You will be surprised to see that it is sugar. We produce more sugar than any other crop. And sugar is not a particularly good nutrient. And that was totally surprising to me, because I thought, well, you know, we produce rice or maize or wheat as the main producers. So this is what we produce most: sugar, maize, rice, wheat, milk, potatoes, soybeans, and so on. So keep that in mind, because these are the big staple items. So what we produce, we don't export a lot. You know, everybody says, well, food export is huge. Well, it's huge in terms of amount produced, but it's not a lot of the total production. So look at rice, only about 5% of the global production is exported. Potatoes, very little. Maize, about 10%, wheat, about 20%. The only two which are really exported in large quantities is soybeans and rapeseed. Both of those are basically for animal feed and for soy. And again, even livestock, we export very little globally. So it's actually very surprising that when you think about, you go to the supermarket and you get food from anywhere in the world, it's not a large amount of what we totally produce. But we have been very successful in increasing the production. Almost every food item you can imagine. Here is potatoes, soybeans, rice, and here's the livestock and the chickens. You can see some of the meat production has increased dramatically, like chicken. So what is quite interesting is how much meat is being consumed around the world. And if you look at the kilograms per person of meat consumed in these countries, it's somewhere between 80 and 120 kilograms of meat consumed per year by mostly Western developed and South American countries like Brazil and Chile and so on, Argentina. These are the big meat consumers. And then you've got all the countries down here who don't consume very much meat. And the reason why I'm telling you this is related to water. And what is interesting now is in the Western world, we have been eating so much meat that we have virtually maximized the amount of meat consumption. We can't really eat more hamburgers every day. So we're actually starting to reduce the meat consumption because we're saying it's more healthy and it's better for the environment. So here's an example where these countries have actually started to reduce their meat consumption. But these are the countries in the emerging world who are actually increasing their consumption. So if you look at Vietnam, Russia, Chile, Korea, Brazil, China, they're all increasing meat production, meat consumption dramatically, whereas in the Western world, because we have all this obesity problem, like Japan and North America and so on, we're actually reducing the meat consumption. So if you look at the two biggest countries in the world, China and India, this is the amount of the population per world. So China has about 19% of the world population, and this is what they produce. So if you look at the items they produce, mostly tomatoes, rice, vegetables, that kind of thing. They produce a lot of vegetables which beyond their population center. And also in terms of livestock, China produces huge amount of pork. In fact, China has 45% of all the pigs in the world. This is their main staple. And if you combine China and India, you can see they're still producing more on these mostly fruit and vegetable items, but not on the basic food items. So both of these countries have been reasonably successful until very recently to produce enough food for their big population. In India combined are about 36% or 37%, or so a third of the population is in India and in China. And until recently, they have been very successful in producing enough food to maintain the population. Many other countries are scarce in food, and so they rely on imports. And there are only, in my view, about 11 countries which have the potential to massively increase food production so that it can be exported to those countries which don't have enough food. So there are 11 countries from Argentina, Brazil, Australia, Brazil, Canada, France, Kazakhstan, Kazakhstan, Russia, Paraguay, Uruguay, US, and Ukraine. These 11 countries, this is the amount of population they have. You can see they are the massive producers of soybeans, maize, rice, and so on. So these countries are the ones who have the potential to produce food for those countries who don't have enough. However, when you then look at how much arable land do these different countries have? So if you look at Mexico and Nigeria and so on, they have a very small amount in terms of hectares per person of arable land, very small amounts. And these are the countries which have still quite a lot of arable land which they could actually use. And remember, like for Canada, climate change is actually positive because we have still lots of arable land, but it used to be too cold to produce things. So as it warms, we have the potential to export or produce more food for export, similar Russia and so on. So if you look at the countries with the smallest amount of per hectare, it's mostly in the developing world. The other problem you need to consider is how much water do these potential countries who export food have? And when you look at these 11 countries, you will see this is the amount of arable land they have, and this is how much water they have. So Brazil has relatively small amounts of arable land, but very massive amounts of water. Russia has pretty good. Canada is pretty good, and the US is pretty good in terms of these two constraining resources. Australia has huge amounts of land, but they virtually have no water. So even if they now are a big exporter, if climate change continues, there is no way they can actually become a greater exporter of food because they don't have enough water, similar to Kazakhstan. And again, even in some of the South American countries, the potential for exporting more food is limited because of the water constraints. So if you rank the countries which are the greatest net exporters in the world, these are the countries which are the big exporters. And in terms of the colors, the red colors means these are the biggest exporters for soybeans. Brazil is the biggest exporter of soybeans, beef, and chickens. The US for maize and pork, and Australia for sheep and so on. That gives you a bit of an idea who is exporting most of the food. These are the countries which import most of the food. So you can see China now is becoming one of the biggest exporters over the last 5 or 10 years. This is now by 2017, the latest data I could get. You can see they're the largest importers of milk, sheep, beef, soybeans, and the third largest chicken and pork importers, even given the fact that they have almost 40% of all the pigs in the world. Why is this? Because China has now improved their economic performance, which means the people are changing their diet from a crop-based diet like rice to a meat-based diet. And so keep in mind, these are the net importers. And if you look at some of these countries, the Middle East, particularly Egypt, Iran, Saudi Arabia, United Arab Emirates, they're becoming big importers because they can't grow very much food because they don't have the water resources and it's getting too hot. So how much water does it actually take to produce the daily diet which you consume? Have you ever calculated what you eat for breakfast, lunch, and dinner? How much water does it take to maintain your diet? So in North America, we use about 5,000 liters per day to maintain your diet. 5,000 liters. Think of a bottled water. A bottled water is about 500 milliliters, so half a liter. So 5,000, that means 10,000 bottles of water is needed to maintain your diet. If you're in the developing world, it's about half. If you look at China, it's about half to North America. As these people change their diet to a North American diet, they will need far more water. And the interesting thing in this is everybody who basically only eats rice is looking for some alternative. And as soon as you have more money, the first thing you do is you change your diet. So keep that in mind, 500 liters of water for your daily diet. I bet you never calculated that or thought about it. So how much water does it take to produce all these crops? if you look at rice, is the most water intensive. This is in cubic meters per ton or liters per kilogram, same thing. So about 2,000 liters to produce a kilogram of rice. Soybeans about 1,700, potatoes about 700. Now switch over to meat. If you like your beef steak and your hamburger, a kilogram of beef takes 16,000 liters of water to produce. So compare that with that. And even pork or chicken in the 3,000 range, all of the meat production requires far more water than any of the crops. So as people move diets, we need far more water. So I also calculated what kind of water it takes for the various beverages. And so you are all conservation minded, so you got a choice. You can either become a teetotaler or you can become a beer drinker. And you can see I am obviously prefer beer from tea. And if I want to be conservation minded, drink beer rather than wine or all the other things. The Italians, of course, drink a lot of wine, and that's a kind of intermediate as opposed to apple juice and milk and so on. So just as an information base, be aware everything we consume uses a lot of water. So how do we actually calculate how much water it takes to produce the food? Well, it's very complicated. You need to know the evapotranspiration, you need to know the crop coefficient in terms of water accounting, you need the crop yield, you need the water amount which it takes to produce all this, and so on. And we can actually calculate it, but like I said, it's very complicated. This is just how to measure the water demand for crops, and this is how you measure the water demand for meat. So remember, we talked about blue water and green water. You now know these differences. We use mostly blue water for intensive agriculture, and we use only green water for rain-fed agriculture. And remember, we said 2/3 of all the water is the green water, which is rain-fed water, and only 1/3 is blue water, and all the intensive production is using blue water. And again, agriculture now is not only the highest water consumer, this is the amount of water it takes to produce food from agriculture, and this is the amount of pollution you generate. So if you look at all the land use activities in the world, agriculture is now by far the largest water consumer and also the largest water polluter, followed by urbanization, mining, recreation, and forestry. This is a general overview on water use and pollution. So if you look now at the virtual water saved by countries, so I need to explain this to you. If you grow a crop in your watershed and then you export that crop, that water which you use to grow that crop cannot be used for anything else in the watershed. So this is called the virtual water trade. So the water which you use to produce the food, which you consume in your own watershed, is okay. But the water which you use to produce food, which you export, that water cannot be used for anything else. So if you're in a watershed like I have in Canada, in the Okanagan, which is the driest watershed, we're now at the point where all the water resources are allocated. There are no new water sources. And so we are exporting from that part because it's the driest and the hottest. We can actually export grapes, pears, peaches, and apricots. That water which we export cannot be used for domestic purposes or other purposes. And so now there's a huge debate in the watershed. Should we actually grow food for export when we don't have enough water for drinking purposes and for industrial development? So if you look at the different countries on how much water they now importing, because if you don't grow that crop, you save water. So if you, let's say, China now imports a lot of soybeans. So they don't have to grow that, so they save that water so they can use it for domestic and urban and industrial purposes. So if you look at this, China now imports virtual water for meat and for crops, and this is in cubic kilometers per year. This is the highest water import, virtual water import of any country in the world. Japan, Mexico, Saudi Arabia, Korea, all of these countries are large virtual water importers. And that means they save that water because they don't have to produce it. So virtual water export by the key countries we're exporting, those are the countries which are losing that water. And if they have enough of that water, it doesn't matter. But if they don't, this is the amount of water they're exporting, virtual water export. I hope everybody understands this. So these are the countries who are exporting water. And here are the countries which are importing water. So the water export and import versus the water withdrawal is a comparison. So you can actually say, how much water do I use in my country every year? And how much do I export? And how much do I import? And so if you look at the US, they use about 482 cubic kilometers per year for all purposes. They export about 176. And this is about 37% of all the water which they use. So in the US, 37% of all the water they use is actually exported. In Brazil, it is over 100. Now, Brazil has obviously lots of water, so they can actually do this. And so these are the countries which are exporting, and you can see they, some of them are almost at 100% in export and what they use. These are the importing countries. And in comparison to the virtual water which they, all the water which they use, I hope that's clear. So these countries import more water than they actually have. So Singapore, United Arab, Saudi Arabia, and so they import more water. If they would have to grow that crop, they wouldn't have enough water for domestic purposes. And so all of these 100% or more, and all of these 50% and so on. So let's have a quick look at what has China done. So this is rice is the main staple in China. So the red is what they export, and the blue is what they import in quantities, in tons. And you can see, since about 2008, massive import of rice. And if you look at chickens, and you look at beef, and you look at pork, all of these, they have started to import all the food so that they can save water for other purposes. Because remember, China, in particular in the north, is water short. And so they have decided that they're going to rely on food imports to save water so they can use it for other purposes. So China has 19% of the human population, 46% of all the pigs, 33% of all the chickens, and so on and so on. And yet, that is insufficient to maintain the demand for food. So they are now importing, and rather than growing it in China, they're importing it. What are they importing in terms of the quantity of the global imports? So if you look at beef from 2000 to 2017, they're now importing 15% of the globally exported or the globally imported meat in beef, about 15%, in terms of sheep, about 25%, and in terms of milk, about 22%. So all of this has increased in a very few years since about 2000. The same thing here is for soybeans. Soybeans has been dramatic, and also for sorghum, most of these for animal feed. What is important about this is look at the water requirement for these crops. This is in cubic meters per ton. So all of these are in the several thousand range. Beef, of course, is 13,000. So if they would have to grow this, this is the amount of water which they would need to grow this food. All of this is very high in numbers. Keep those in mind, 2,000, 3,000, 4,000, 5,000. What are they exporting? They're exporting garlic. The biggest export of China is garlic, melons, onions, that kind of stuff. And all of these are very water efficient crops. So they're only producing food for export, which is water efficient. And this is important because I want you to see the next graph. When I was working in China on this Watershed project, the big discussion was in 1990. Remember, the reason why China was so successful in producing food is they let the farmers bring their own stuff to market. So they actually allowed free enterprise, and this is really where the success was for China to become food self-sufficient. And then in 1990, they started to talk about sloping land. That's getting into the mountain part. And then everybody said, well, we should also allow farmers to grow stuff on sloping land. But remember, sloping land is much more hazardous because if you do conventional agriculture, you create huge amounts of soil erosion. So the big discussion was, what should we grow on the slopes? And then eventually people said, well, why don't we grow trees which produce food on these sloping lands? And so they went on a massive campaign to grow orchards, pears, tangerines, peaches, grapefruit, and so on these sloping lands. And this is the amount of water which is used for these. Again, compare that to all the stuff they're importing. They're all water efficient crops. So China now only imports water intensive food and only exports water efficient food. So if you look at this in total terms, here is 2000 and 2016. This is the amount of water which they're importing. And most of it is in terms of soybeans, which is probably the largest thing. And this is how it has changed. So if you look at this in terms of the estimated water use, China uses 69 cubic kilometers of water for domestic purposes. They use about 133 for industrial purposes and about 377 for agriculture. That is a total of 579 cubic kilometers for the total water use of all the activities in China. And they're importing about half, more than 49% of what they're importing is virtual water. They're saving that kind of water so they can use it for these purposes. So the import is 4 times higher than all the domestic water use, twice as much as the industrial use. And remember, they're very smart. Agricultural crops are cheap. Industrial products are expensive. So if you trade off food production to agriculture, you save water and you make more money. How does this apply to the Middle East and North Africa? Remember, these are the very dry countries, and in terms of climate change, this is critical. So if you look at the population in 2000, in 2020, and the projected population by 2050, so you can see there's going to be a massive increase in population. This is looking at all of these countries. I think there are 19 or 20 countries I looked at. So this is the population growth. Remember, each continent has different diet priorities. So if you look at the Middle East and North Africa, they are the big consumers of wheat and also of corn. So other countries don't eat, except for Europe. Europe and the Middle East are the real wheat consumers, whereas the Asian countries are more rice consumers. So anyway, this is the change as it has happened over the last 20 years. So if you look at MENA countries, they have 21% of the global trade, 22% and so on. And there has been a massive change in the amount of food imports. As an example, Jordan imports 4 times more water in food than they have available. If they would have to grow their own food, there is no way they could actually have enough water for domestic purposes. So as climate changes, the demand in those countries which are water short, they're going to rely on imports from other countries to save water. So let's see what has happened in the Middle East. The imports of wheat, which is their main staple, is in red, and the production is in green. And you can see we're now at the point where the imports are equivalent to the production, and as the climate gets warmer, the imports are going to exceed the production. So if you look at the scenario for 2050, this is the production. This is the 2016, the current production, and this is in million tons, what they expect to need by 2050. And this is the virtual water which they're going to import as we go along. So let's look at the case of Egypt. Egypt now, the change in wheat production and imports. Again, the imports are in red and the green is what they produce. They are now relying on more imports than they produce. So the available water in Egypt is about 68 cubic kilometers. The virtual water import is 8 in 2016, but this will go up to about 13 by 2050. For maize, the same situation. So virtual water, wheat, and maize imports is 21% of the available water, but uses about, but will probably increase to 38 if business as usual. So remember, 2010 was this hot year, and Russia is a big exporter of wheat. And you can see what happens when there is a drought in one of the exporting countries. Egypt imported, you see the production in green. And in 2010, when we had this big drought in Europe, you can see the production went down dramatically and the imports went up dramatically. And so if you look at the global wheat export in Egypt, you can see it's increasing dramatically. And the wheat export of Russia has also increased dramatically. But in 2010, there was a dramatic drop in the amount they could export because of climate change. So Egypt now is at the point where the annual withdrawal is about 68 cubic kilometers. Oops, sorry. And the import is about 28, and the domestic water is about 5. That means the virtual water is about 40% of all the water they use. So again, look at the population and look at the arable land. These places are going to be much more dependent on those countries which can export food. And we had a project in the Sahara in Egypt where they do water harvesting, and I will talk about this a little later, where you collect the rainfall from a small watershed when it rains, put it in an underground storage, and then use it when you don't have water for irrigation. So let's look at Saudi Arabia, because that's probably the best example I can give you where climate change is happening at an accelerated rate and is having a huge impact on food consumption and food production and virtual water imports. Population in 2016, 32 million, estimated 45 million, arable land per person about 1.1 hectare, by 2050 probably 0.5 hectares. Remember, a hectare is about 2 football fields, 2 soccer fields. So if you look at Saudi Arabia, my colleague, the Professor Lafgalich, was sent to Saudi Arabia in 1985. And he was sent by a commission, an agricultural commission from Canada, because Saudi Arabia was interested in increasing their food production. So in the 1980s, they started to produce wheat in green. And with the help of all foreign aid, they were able to increase wheat production dramatically. And they actually exported wheat during the 80s. This is in blue. This is what they exported, and this is what they imported. So in the 80s, they didn't import anything. They produced a lot, and they exported a lot. And then in the 80s, it started to change. They didn't export anything, and they still produced quite a lot. And by 2008, they started to import. And in 2020, they said they will no longer produce any wheat in Saudi Arabia because they don't have enough water. So you can see now Saudi Arabia is going to rely almost exclusively on food imports because they don't have the water. Now, they said, well, we got a lot of energy, so we could actually use desalinated water to produce the food which we need. So they did actually a calculation on how much energy it would take to actually produce enough wheat for their consumption. And they figured it would be a quarter of all their oil revenues. So there is no way they can actually do this with desalinated water. You can do desalinated water for domestic purposes because you don't use a lot of domestic water compared to agriculture, but you could never use desalinated treated water for agriculture from an economic point of view. So you can see the wheat production or the wheat imports in red and the wheat imports in corn are going to go dramatically up in Saudi Arabia because they're running out of groundwater. Because all of their operation all the production was done by groundwater, and they have now depleted their groundwater resources that they can no longer produce food. It's a very drastic example to show how climate change is going to affect all these areas. So in terms of Saudi Arabia, total annual withdrawal of water is 23 cubic kilometers. Virtual water import exceeds what they have, and the domestic water is minuscule compared to what they import. So if you look at the Middle East region, the blue is water they have, and the red is the water they import. So almost all of these countries will rely on food imports to save water and so that they can maintain population. And as long as you are economically viable, you can afford to buy the imports. So for the region as a whole, you can see the production will not increase very much, but the imports will double over the next 50 years if business as usual. And the amount which will be imported will be higher, and the amount of water which they import will be higher. And the withdrawal will be pretty much the same or will probably decline, because if they use a lot of groundwater and it's not recharged, there is no way they can actually have more water. So all the projection by climate change is that region, the North African to Middle East region that is now, and that is at the end of the century, these are the areas which are going to warming up faster than anywhere else. And if you look at the precipitation projections, again, here's North Africa and the Middle East. This is where the decline is probably going to be the greatest, and this is going to affect the activities dramatically in how we manage these things. So I showed this before. There's all kinds of things we can do to improve things a little bit, but we cannot do it at a very large scale. The other thing you need to remember, we are now in a very fragile environment because we have concentrated everything in certain areas. What I'm showing you here is where in the United States do they grow soybeans. So this, the dark green area is where they grow all the soybeans. And this area exports about 48% of all the sorry, this is maize. I'm sorry, I made a mistake here. This is where they grow all the maize in the world. It's the highest producing area of maize. And 48% of all the global export from maize come from this small area. Now imagine if you have a flood, or imagine if you have a drought. What happens to the global export, and what happens to the countries who rely on these exports? This is something we really need to pay attention to. This is soybean, same situation. This is the area which produces 45% of all the globally exported soybeans in 2011. And this is in 2018. This is the area which soybeans were grown in the US. So the percent of change in exports is of concern. So the green is the amount of maize which was exported by the United States. And you can see what happened in about 2012. All of a sudden, the amount of maize export has declined dramatically. The amount of soybeans has pretty much stayed the same, but maize has gone down dramatically. Why is this of interest? Why did they reduce the maize? Because, because they started converting maize into biofuel. They said about 5% of all the gasoline should have biofuel. So they used maize and took it away from their exports in order to generate more biofuel. And this is the problem in almost all areas where people say we should go for biofuel. This is taking away food for exports for many countries who will need it in the future. And the thing which is of real concern is every time we have a drought, the price index of wheat changes. So I put this up for interest. Here was the 2003 drought in Europe, and you can see there was a small amount of decrease in the index. Here is the Australian one, an increase in the price of global cereals. Here is the Australian drought. Right after the drought, the prices increased. Here's the drought in Russia, the prices increased. Here's a drought in Texas, small increases. Here's a drought in the Midwest and the increases. So you can see how climate change is affecting the global economic situation for all the food. So the food challenge for the mountains is right now we have mostly insufficient food, a lot of poverty problems because of malnutrition. And in the future, can we actually improve this food production? And I would say, yes, we have all kinds of opportunities because of climate change. So right now we have low yields, we have a very harsh climate, we have short growing seasons, we have inefficient irrigation, and we have limited crop biodiversity. We could go to higher yielding crops, legumes, and use more leguminous crops, so we don't need as much fertilizers. We have a longer growing season. We can do much more efficient irrigation by drip irrigation. We can have greater crop biodiversity. So there is potential to increase the food production. We're actually doing this now in the Columbia Basin. We had a number of workshops and looking at what new crops could we grow in these new areas which are warming up faster in the mountains. So the food import challenges for the mountains is much more difficult than in the lowland because the access to import food is very difficult. You also have very poor infrastructure because the roads are precarious and they always get damaged. Storage, there's very little storage available in the mountains and high transport costs. But more challenging for food imports is the incredible increase in urban demand, first of all from the big cities in the mountains, but secondly for all the recreational urbanization. Remember, all these tourists come in and they want to eat the same amount of meat and food than they do in the city, which means that stuff has to be imported, and that is going to become a big issue. And there will be higher cost involved, and we'll have more risks in terms of food and drought. So for the mountains in the future, this is going to be much more challenging in the urban and tourist areas, but there is potential for the most rural areas to improve the food situation. So that gives you a bit of an idea of what kind of issues we're facing with food security. And I hope this virtual water idea gives you some ideas how you can actually reduce your water footprint. And I would encourage you not only to look at your financial footprint, but your carbon footprint and your water footprint. And there's a very good website which you could look up, looking at your water footprint and determine how much water do you actually use and how much of that water you could actually reduce. And this will be the discussion for my next presentation after we have some questions.
Okay, Hans, thank you very much. There are 3 comments, but before them, I would like to make an announcement for the concerning tomorrow lectures. Tomorrow lectures will be according to Rome time zone at 9 a.m. So don't connect yourself in the afternoon, but at 9 a.m. till 1 p.m. Okay, so coming back to the questions. Okay, there is a comment that Albania has plenty of hectares of cultivated area of medicinal and aromatic plants, and Albania is the leader in the production of those cultivation. Just for our knowledge, that our friend from Albania comment this.
Well, if you want to get some really good information on how to produce medicinal plant in the mountains, Bhutan is the country you should look at because they have focused on trying to preserve all these diverse plants, which we don't have a lot of knowledge for medical purposes, and they actually have demonstration sites and research areas where they do this quite extensively, and this is something which could help you in terms of looking at a crop which has high value uses relatively little water and can be grown in mountains.
Okay, then there is a question from Lupa that asks, to reduce massive usage of water, does it require now one to produce or grow own food? And then also a country should rather rely on its local market for homegrown products, or striking a balance is critical?
Well, I mean, we have now a real push to produce food locally consumed. There is an author about 10 years ago who wrote a book which is called the 100-Mile Diet. In other words, you should eat the food which is grown within the 100 miles of or 100 kilometers of your place. Well, this is okay, but this is very difficult for a place like Canada. If you try to eat local food in January, February, and March, when the temperatures are -30, you will not find very much food, and it's very boring food. So yes, we have a push to have locally consumed stuff. That works very well in the summer when we can actually produce lots of it. But in the wintertime, that doesn't work. And in the mountains, that's also a problem, right? So you can do a little bit by greenhouses and solar and all that kind of stuff, but you can't do it at a massive scale. So even in the mountains, you will be relying on imported food during periods of cold temperatures.
Okay, thanks. Then a question from Antonio. Probably the problem is that energy and food now are commodities, so profit is the driver that governs their production. They should be human rights, and the driver must be satisfaction of human necessities.
Well, that's, yeah, I totally agree, but this is something which the social scientists and the political scientists and the economists have to address. This is not something I can address as a scientist dealing with water and climate change. So some of you are experts in this area, and you can probably address this far better than I can.
Okay. There is a kind request of a toilet break. So, and I totally agree, first of all. So, if you agree, we can make another 5-minute stop.
Yeah.
So I'm stopping the recording, and then when you are ready, I start again the recording, and I give you the word.
No problem at all.
Okay, see you later in 5 minutes.